Hey guys, how are you? Next topic for this unit is on, as you can see, kind of up here over my head, is that it's about adiabatic cooling, something you've probably never heard of, and that's okay for right now. But in other words, the short version of adiabatic cooling is, in other words, how clouds form, and I'm going to write that in just a second. Today's topic is really about clouds, how they form. We will talk about different types of clouds and generally what they mean about weather as we get further into our unit. But first we need to understand how do they form in the first place. Okay, so like I said, as you're watching, definitely be taking notes on what we're doing. But adiabatic cooling is, in other words, how clouds form. Okay, so I'm going to explain it to you in steps with explanations over here on this side, and then we're going to add some visuals afterwards to kind of show you what it means. So first, here are our steps. The first thing we need to know is just reminding ourselves of something that we talked about early on, and that's that warm air is less dense than cold air. Cold air is more dense, warm air is less dense, which, if you think about it, okay, what floats? Does anyone ever go cold air balloon riding, or do they take hot air balloon rides? A hot air balloon floats, and it floats because the hot air inside the balloon is less dense and will start to float or rise in the cooler air around it. Okay, so like I said, I put that as a way to help you remember, and that's that we've hot air balloons, not cold air balloons. Cold air balloons aren't going to go anywhere, but a hot air balloon will. Okay, so that's something we need to know, is that warm air is less dense. And if it's less dense, well, then first of all, it's going to rise. And as it rises, it's going to expand and cool. Okay, it expands and cools because as we go up away from the surface, air pressure decreases. So there's less pressure pushing in all directions. So since there's less pushing inward, that pressure can push outward and allow that air to expand. Well, if it expands, there's more space in between, so there will be less heat, or that heat will be distributed over a much larger area. So the temperature will decrease. Okay, so the warm air rises. If it rises, there's now less pressure. If there's less pressure, it will expand, and I'm going to put here less pressure. Well, if there's less pressure, like I said, it will expand. And if it expands, that heat is now spread over a larger area, so the temperature drops. The same amount of heat, more space, so temperature drops. Okay, so the warm air rises, it expands, and it cools. That's important to know. Okay. The next thing is that if it cools, well, the amount of moisture isn't going to change. Okay. And if you look back or think back to what we did when we were talking about humidity, warm air is able to hold more moisture than colder air or than cooler air. Okay. That's why if you get a drink with lots of ice in it on a hot day, you go back to pick it up and the outside of the glass is wet because the air around the outside has cooled and you get condensation. Well, the same thing is going to happen here. Okay, what's going to happen? RH for relative humidity. The relative humidity is going to increase all the way up to 100%. And if it continues to cool, then you get condensation. And the condensation are clouds. So if you look up at clouds, yes, we know that clouds, people say that clouds are made of water vapor. That's not exactly true because water vapor is a gas and clouds are not made of water vapor. They're not made of gas. They're actually made of droplets of liquid water and oftentimes actually made of crystals of frozen water because it's so cold that that liquid water freezes. So many of the clouds are actually made of tiny little ice crystals. Okay. However, there's enough pressure coming up from the ground that it allows them to stay afloat up in the sky. Obviously, if those droplets get to be too heavy, they will collect and they will fall, and that's precipitation or rain or snow, depending on the weather. But more about that another day. Okay, there's one last thing that we need. Okay, and the last kind of ingredient in making clouds are something called condensation nuclei. Okay, condensation nuclei is something for the condensation, for something for those water droplets to stick to, bits of dust or other solid particles, dust or smoke, particles that are in the air. If the air was totally clean and clear, there'd be nothing for the water to condense onto. It can't just come, it's got to have something to stick to. Okay, that's why in your bathroom when you get out of the shower, you don't have condensation everywhere, but you see it on the mirror because the condensation has something to kind of stick to. The mirror acts as condensation nuclei. Up in the sky, it's bits of dust or smoke or other particles that happen to be floating in the air. Okay, so let's take a look now, like I said, about what all of these mean and how can we show that. Okay, so let me get a thinner pen. Okay, and we'll start on the ground. Okay, so here's the ground. Okay, this is the ground. Okay, and what we have going on, we're going to start with warm air right here. That's warm air. Okay, well, just like we said, the warm air is here, and we'll put some cooler air around it. Cooler air here, cooler air here, and cooler air over here. Okay, well, if this warm air here is going to be cooler, or excuse me, the warm air here is going to be warmer than what is around it, it's going to be less dense. Well, if it's less dense, it's going to rise. Okay, because remember, less dense things always rise or float on top of more dense things. Think about that glass or that ice cube that you put into a glass of water or into your drink. The ice is less dense than the drink, so the ice floats to the top of the drink. Okay, it doesn't stay on the bottom of the glass. It floats to the top. Okay, because it is less dense. That always happens. Okay, well, as the warm air rises, there is less air pressure up here. So let's label that less air pressure up here. There's less air pressure, so the air that used to take up a small amount of space is going to expand and take up a much larger space. Okay, so here it's cooler, it's cooled off, okay, and it expanded. Well, it cools because it expands, because the same amount of heat that used to fill up this tiny little space now fills up that huge space, so less heat per area or per volume, so the temperature drops. So the temperature decreases, the temperature drops. Okay, well, because the temperature is dropping, the relative humidity is increasing. Okay, so bottom line, this is what we need to know. Okay, this is our mantra. This is what we need to keep saying in our head. Warm air rises, expands, cools, and condenses. Okay, say it again. Warm air rises, cools, expands, and condenses. I changed it that time, and I'm sorry. Okay, it expands, which causes the cooling. They're all connected to each other. Okay, warm air rises, expands, cools, and condenses. That's what gives you clouds. Warm air rises, expands, cools, and condenses. Say it again, one more time. Warm air rises, expands, cools, and condenses. And that's how you get clouds.